What's up, Math 8? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at lesson 5.3, how to compare and order numbers. Specifically, we're going to see a lot of like fractions, decimals, square roots, and cube roots. So we're going to kind of combine what we've been seeing so far and be able to order them from least to greatest, greatest to least, maybe even compare them using less than, greater than, or equal tos. What we're going to do here is we're going to talk about what happens when we see different forms. So what we want to do is make sure we put them in the same form. So a lot of the times that same form is going to maybe be in decimal or integer form. Okay. For example, this is the square root of 4. And right now it's in the square root form, but if I wanted to solve it, putting it in integer form, I would say it's equal to 2. And then I can compare 2 to 3, saying that 2 is less than 3. So my original problem, I would say the square root of 4 is less than 3. Over here I have the cube root of negative 8. I'm going to go and solve that. That's negative 2. And then negative 4 over 2 is also equal to negative 2. So I would say that since negative 2 is equal to 2, the cube root of negative 8 is equal to negative 4 halves. Why don't you take a moment and pause the video here, see if you can estimate what these would be equal to, and when you're ready to check, click play. All right, I know this first one's in decimal form, so I don't have to do anything with that, but 10 over 3 is not. I know I can think about this as maybe a mixed number. 3 can go into 10 3 times with 1 left over. So 3 1/3. I know 3 1/3 is equal to about 3.3. And since that is smaller than 3.4, I'm going to say 3.4 is greater than 10/3. This next one, notice how we have not a perfect square. And this is actually close to 16. The square root of 16 is equal to 4, but notice how 15 is right below 16. So when we estimate this, we could say it's maybe like right before 4, like 3.9, whereas this number is 4. And automatically I can say 3.9 is less than 4, which means the square root of 5 is less than 4. Here are a few more. Let's go ahead and pause the video again. Try these on your own. When you're done, click play. All right, square root or cubed root of 64 is equal to 4. The square root of 16 is equal to 4. So since 4 is equal to 4, I know the cube root of 64 is also the same thing as the square root of 16. Moving over here, I want the square root of 225, but a negative. That's going to be negative 15. And negative 31 halves, 2 can go into 31 15 times with 1 left over. So this is negative 15 and a half. The thing you need to remember about negatives is when you compare negatives, the bigger the number it is, the smaller it actually is on the number line. So in this case, I'm going to say negative 15 is greater than negative 15 and a half, which means the negative square root of 225 is greater than negative 31 halves. Again, here are some more examples to try. Let's pause it, try these on our own, and when you're ready to check, click play. All right, this first one, still a decimal, negative 7.9. But over here, I have negative 8. According to my rules of comparing negatives, the bigger the negative, the smaller it is. So negative 7.9 is actually larger here, which means negative 7.9 is greater than the negative square root of 64. Over here, if you realize 0 over 13 is equal to 0, and the square root of 1 is 1, the square root of 25 is 5. 1/5 is actually equal to the decimal 0.2, but you can also keep it as 1/5, and you're just comparing it to 0. Either way, 0.2 or 1/5 is larger than 0, so that means 0/13 is less than the square root of 125. Now we're going to move on to putting these numbers in order from smallest to biggest. So what I need you to do is convert all to decimal or integer form. Okay, so that's what we're going to do first. Then when we're done, we're going to write them back in their original format. Here we go. 3/4 is equal to 0.75. Then I have negative 0.75. The square root of 6 is not a perfect square. It is right in between the square root of 4 and the square root of 9. And since it's closer to 4, we're going to say it's probably closer to about 2. Okay, then we have 0.625. The square root of 9 is a perfect square. That's equal to 3. And then pi is a decimal, 3.14. The first thing that is smallest is this negative 0.75, which in original form is still negative 0.75. Next up, we would look at our decimals, and we would see that this 0.625 is the next one, which is still a decimal. Following 0.625, we have 0.75, but original form is 3/4. Okay. Next up, we would probably say this 2 would be our next biggest number. So that's the square root of 6 in original form. Then the square root of 9, because that's equal to 3. And then the last one is pi being 3.14. So this would be my order from least to greatest back in the original format. At first, this looked kind of crazy because we had different forms, but once we write them all as a decimal or integer forms where we're solving our square roots, it's a little bit easier. Here's the next one I want you to try. Let's go ahead and pause the video here. Try this one on your own, and when you're ready to check it, click play. All right, the first thing I'm gonna do is write all these in decimal or integer form. So I've got negative 1.2. 4/5 is 80% or 0.8. This one is 0.5 repeating. Negative 7/8 is 0.875. And then the square root of 7/8 is not a big number. And really, if you think about the square root of 7 and the square root of 8 is not perfect squares, but we do want to try to find the closest ones to that. So if we think the square root of 7 is closer to 9, so that's going to be 3. And the square root of 8 is also closer to 9, so that's also going to be a 3. So that's equal to about 1. Now let's see what happens when we try to put these in order. All right, now that we have these in decimal integer format, let's go ahead and pick the smallest one, which is going to be our obvious negative. So this is negative 7/8. But I just realized we also have another negative, and that negative is actually way smaller because it's further down. So negative 1.2 would actually go first. So I've got negative 1.2 is first, then negative 7/8. My next one is probably going to be between one of these positives. I've got 0.8, 0.5, and then a whole number 1. I'm going to use my 0.5 repeating next because that is less than 0.8, which would be the 4/5. So this would be option 3. This is 4. And then my final one left over is the square root of 7/8. Okay. We've got 2 more examples. The last one is actually not terrible. So let's go ahead and try these. Again, thinking about what they could be in their formats of decimals, I have 0.3 repeating, negative 0.6, negative 0.75, 1.2, and negative 1. Starting with your negatives, the highest negative I see is this negative 1. So that's going to be the cube root of negative 1. Okay, then my next highest, biggest number, which would be my smallest one, is negative 3/4. Then I've got my negative 0.6. Okay, finally after that, I've got my 0.3 repeating, and last but not least is my 1 and 1/5. Okay, with these, I like it when we compare all of the square roots because the smaller the square root, the smaller the answer is. So to be honest, all you have to do is write them in least to greatest order from what you see currently. So 2, then 5, then 8, then 11, and 17. So the square root of 2, square root of 5, square root of 8, square root of 11, and then square root of 17. Mainly because 2 is closest to 1, 5 is closest to 4, so that's 2. This is 3. This one would be a little bit bigger than 3, like 3.3, and then this one would be closer to 4. Okay? The nice thing about this, since they were all in square root form, it's easier to compare them when they're all in the same format. So I wanted to show you this example just because you see a square root doesn't mean you always have to solve it. Next up, put the numbers in correct order from smallest to biggest, solving as we go. So we got 4, 4.2, 10. 2 goes into 19 9 times with 1 remaining, so 9.5. And then the square root of 80 is very close to 9, but not actually equal to 9. So that would be closest to the square root of 81. So I'm going to say that's about 8.9. Okay. Smallest is 4, square root of 16, then 4.2, then the square root of 80, then 19 over 2, and finally the square root of 100. Okay. And then last but not least, we have one more example. Again, we're just solving as we go. The square root of 49 is closest to 7. The square root of 63 is closest to 8. we have 7.3. 2 goes into 15 7 times with 1 left over, so 7.5, 5, and then 8.5. So lowest number I'm seeing is the 5 here, so square root of 25. I don't have any 6s, I do have some 7s though, so square root of 7 would be next, or square root of 49 would be next, which is a 7. Then I've got 7.3. 7.5, remember, is 7.5, so I probably should have written that, which will be my fourth one, 15 halves. Then square root of 63, and last but not least, 8.5. Okay. The last little bit, I just had practice for square roots and cubes. If you want to pause the video here, now would be a good time. Otherwise, let's go ahead and get into it. 16 squared is 16 times 16, which would be giving you 256. 9 squared is 9 times 9, 81. Negative 5 squared means to do negative 5 times negative 5. Notice how it's in parentheses. That means you carry the parentheses. You're going to get a 25. Square root of 144 is 12. Negative square root of 64 is negative 8. The square root of 289 is 17. 4 cubed is 64. 9 cubed, but a negative is going to give us a not negative answer. So that's negative 729. And 7 cubed is 7 times 7 times 7. Or you can do 49 times 7, which is 343. Negative 512. Cube root is negative 8. That would be 64 times 8. Cube root of 1 is 1. And then the cube root of 216 is 6. Okay, just a little practice in there for you at the very end. Thanks for tuning in. Hope this video helped you. Make sure to write all your numbers in the same format to be able to compare them easily. Thanks for tuning in, and we'll